Welcome to our third help video. This one begins on page 3 of the 3B13. Question 17 through 20 deal with the hyphen notation where it says zinc hyphen 64. So what did they tell us? They told us it was zinc. What else did they tell us? What does the 64 indicate? Well, if you forget what the 64 indicates, understand when you use hyphen notation, what they are assuming you have with you to use is the periodic table of elements. So let's take a look at the periodic table of elements. We found zinc right here, and there's a 30 in zinc square, and then a 65.38. There is no 64. So what do we know about the 30? Well, the periodic table is arranged according to increasing atomic number. 28, 29, 30 zinc, 31's gallium. That 30 is the atomic number. That 30 is telling us that all zinc atoms must have 30 protons. So we know zinc has 30 protons. So what's that 64 telling us? It is the mass number of that particular atom of zinc. That particular atom of zinc has 64 particles in the nucleus. Again, from the periodic table, of those 64, we know 30 of them are protons. This decimal number right here, the 65.38, that is the average mass of the naturally occurring isotopes of zinc, and it is a weighted average. So the average of zinc atoms is 6538. This particular zinc atom right here has a mass of 64, or mass number of 64. How many neutrons does it have? Well, if there's 64 total particles in the nucleus, we looked on the periodic table, 30 of them from the periodic table, 30 of them were protons. So if there's 65 total particles, or 64 total particles, and 30 of them are protons, 64 minus 30, 34 of them must be neutrons. 34 neutrons, 30 protons gives us 64 total particles. That's letter D, 34. How many electrons does zinc 2 plus have? Remember, when it's positive, that means there's more protons now than there are electrons. So how many electrons did zinc start with? Well, if zinc started with 30 protons, which are positive, it also started with 30 electrons. But now there are 2 more positives than negatives. So that means if there's 30 protons and there's 2 more protons than electrons, now that it's 2 plus, that means there must be 28 electrons. So remember, if it's positive, it's lost electrons because now there's more positives than negatives. 30 minus 2, 28 electrons. That's letter A. Number 19, how many nucleons does it have? Nucleons is just a fancy term for any particles in the nucleus. They told us the mass number was 64, which is telling us there's 64 particles in the nucleus. That's not the actual mass of zinc 64. The actual mass could be a little bit less than 64, a little bit more than 64, depending on how much of the energy or how much of the mass of the protons and neutrons went into binding energy to hold that nucleus together. So nucleons, there's 64. What's the atomic number? Well, they don't tell us the atomic number here directly. Zinc hyphen 64. They did tell us it was zinc, but again, they assume you have a periodic table. So we look on the periodic table. There's the atomic number right there. That atomic number is telling us how many protons it has and how many electrons it starts with. Letter B, 30. Next group, number 21. Which of the following nuclear symbols shows the nuclide to 64, zinc 64? Remember, nuclides are the exact same atom. So they are identical twins. So they're saying which nuclear symbol is an identical twin to zinc 64. Remember, in nuclear symbol format, the number that goes as a superscript is the mass number. The number that goes as a subscript is the atomic number, or number of protons. That's the way they must do it when they write a nuclear symbol. On the periodic table of elements, there is no prescribed place for all the little numbers to go. but on a nuclear symbol, this is how they must go. So we already learned up here that there was the mass number of 64. That's what a hyphen notation is telling us. So we need one where there's a 64 right here, because a nuclide has to have the exact same protons and neutrons. It has to have the same mass number, it also has the same atomic number, or it wouldn't be zinc. So we're looking for a 64. And then we're looking for a 64, so that gets us as possible answers, A or B. But we need the one that's a zinc atom. Remember, the atomic number for zinc atom was 30. That's letter A. 34 is not even zinc. They wrote zinc in there. 34 is not even zinc. If you look on the periodic table, number 34 is selenium. They can't write zinc in that square. It's selenium. 34 selenium. 34 selenium. 64. Atomic number of 64 is not zinc. Atomic number of 64 is definitely not zinc. If we look up here, atomic number 64, where does that take us on the periodic table? It takes us right down into here. Look at number 64. There it is right there. It's not even zinc. In number 22, they're wanting to know which one's an isotope. Remember, isotopes are twins. They're just not identical. So an isotope, for it to be a twin, it has to have the same atomic number. So again, we're looking for something with an atomic number of 30. The only two that have an atomic number of 30 are A and C. Letter A, we already learned, is exact same atom as zinc 64. So that was a nuclide. Hopefully letter C then will be the isotope. Isotopes have same atomic number. In other words, same number of protons, but there's a different mass number. The mass number on this one is 66. The mass number on zinc 64 is 64. So letter C is the isotope. Next question, who is the mystery atom below? The mystery atom below is easy to figure out. If we remember Moseley, who said it's the atomic number that determines the chemical properties and behaviors of the element, it is the atomic number that determines what element an atom belongs to. So we know the atomic number here is 28. So we go to the periodic table of elements. Atomic number 28 is nickel. Atomic number 28 is nickel. So that atom is nickel, letter A. 24. Which one of the following statements is false concerning isotopes? Remember, isotopes are twins, but they're not identical. So that means for them to be twins, they have to have the same atomic number, which is same number of protons. But it must have a different mass number, which is protons plus neutrons, or different number of nucleons, because protons and neutrons are nucleons. In other words, the isotopes are atoms of the same element that have different masses. Why do they have different masses? Because there's different numbers of neutrons in the nucleus. So let's go through. Letter A, are isotopes same atomic number? Yes. Different mass number? Yes. Letter A is true. Do isotopes have the same number of protons? Absolutely. If they have the same atomic number is number of protons. So it must be same number of protons. But different numbers of neutrons. Correct. If the mass number is different and the number of protons are the same, then the number of neutrons has to be different, because mass number is protons plus neutrons. Isotopes have different masses. They do. Why? Because they have different numbers of neutrons in the nucleus. Isotopes are atoms that have the same number of protons. Yep, but different number of nucleons. That's true. Nucleons are a term for any particle in the nucleus. Isotopes are the atoms that have different numbers of electrons. Electrons really have nothing to do with isotopes. Isotopes relate to differences in the nucleus of the atom. Different numbers of electrons would be saying that they have different ions. Atoms that have different ions are not isotopes. Some atoms can have multiple charges. Some atoms might be able to be +2 if they lose 2 electrons, or +3 if they lose 3 electrons. Yet they are still atoms of the same element because they have same numbers of protons. They're just different forms of the ions. So electrons have nothing to do with isotopes. Electrons are outside the nucleus. Which one of the following statements is false? Neutral or normal atoms? Neutral or normal means they don't have a charge. If they don't have a charge, that means that the positive particles must be offset by the negatives. In other words, the number of protons is offset by the number of electrons. They have equal numbers of protons and electrons. Here it's saying they have equal numbers of neutrons and electrons. Letter A is false. Neutrons are neutral. They have nothing to do with determining whether an atom is neutral. This will take care of our video over the 3rd page of the test. Our next video will pick up with the 4th page of the test.